Hi everybody, welcome back to my lesson. I'm Mr. Idris, physics teacher at Paris Private School. Hope you are all doing well. And before we get started a new lesson, I would like a quick reminder to all of you to subscribe to my YouTube channel, hit the red button, and don't forget to click on the little bell. That way you will be notified every time when I upload a new lesson. If you remember in a previous lesson, we have talked about the rotational and translational equilibrium. Okay? In rotational equilibrium, when does an object considered to be a rotational equilibrium? When the object at rest without rotation, or when an object is rotating with constant angular speed. Okay, in that case, the net torque on the object is zero. So when does an object considered to be a translational equilibrium? For the translational equilibrium, if the object is at rest, there is no velocity. Okay. Or if the object is moving with a constant velocity, such as a car is moving on a straight path with constant velocity. In that case, net force acting on the object is zero, and the acceleration also becomes zero. On today's lesson, we're gonna solve some questions that related with the rotational and translational equilibrium. Look at some questions. A bicycle tire on a flat road. The question is about what? Bicycle tire on a flat road rolls. Look at this question. A bicycle tire on a flat road rolls at a constant angular speed, and the bicycle has, which of the following is correct? Look at this question. Because the bicycle is rolling, okay? The tire of the bicycle has angular speed, but the center of mass of the tire has translational motion. Okay, so in that case, when the question says constant angular speed, when the angular speed is constant, it means that omega initial is equal to omega final. Also, V initial is equal to V final. Why? Because angular speed and the velocity is directly proportional to each other. According to this relation, at constant radius, the radius of the bicycle tire is constant. When angular speed increases, what happens to this velocity? The velocity also increases. When angular speed decreases, velocity decreases. When angular speed is constant, velocity also is constant. As you know, velocity describes the speed of the center of mass of the object. Okay, so every time when the object is rolling, it means that this object has both types of motion, rotational motion and translational motion, such as a bicycle tire, such as a bowling ball when it's rolling. Okay, in that case, when the bowling ball is rolling, it has rotational motion around a diameter. Okay, and also its position changes continuously. That is why we can describe the center of mass as a translational motion. Okay, so when omega is constant, net torque is equal to zero. When velocity is constant, net force is zero. When net torque is zero, it means that the object has rotational equilibrium. So when the net force is zero, it means that this object has translational equilibrium. In this case, in this question, the bicycle has both rotational and translational equilibrium. Why? Because the bicycle's tire rolls on the flat road. Okay. Question 2. A tire's automobile slows down. Be careful. When the tire's automobile slows down, what happened to the velocity? Velocity decreases. Okay. When velocity decreases, it means that V initial is not equal to V final. Okay. When the tire's automobile slows, or angular speed of the tire also decreases. It means that omega initial is not equal to omega final. Okay, so in that case, net force is not equal to zero. This object has no translational equilibrium. When omega initial is not equal to omega final, it means that the summation and the net torque is not equal to zero. So that is why you have to say the car does not have any rotation and translational equilibrium. Okay? A ceiling fan. Be careful. Some object has both types of motion, rotational motion and translational motion because it is position changes. But if you look at the ceiling fan, be careful, please. The ceiling fan has only rotational motion. The ceiling fan is fixed, okay? Has no translational motion. When the question asked is about the ceiling fan, you have to say always the ceiling fan or the fixed object, when it is rotating only, it has always translational equilibrium. Why? Because its velocity is 0. The ceiling fan cannot change its position. Its position is fixed but can rotate only. Okay? When the question says a ceiling fan rotates at constant angular speed, for the ceiling fan, be careful. Delta V is equal to 0. It means that the ceiling fan is always at translational equilibrium. But when the questions say the ceiling fan rotates constant angular speed, it means that omega initial is equal to omega final. Okay? And so in that case, delta omega is equal to 0 and the net torque also equal to 0. When the question says ceiling fan rotates at constant angular speed, the object, the ceiling fan, has both rotation and translational equilibrium. Okay? Another question, the same question. A ceiling fan rotates and slows down. Slows down. When we say slows down, its velocity doesn't change. Be careful. For the ceiling fan has no velocity. It is fixed. Change in velocity always equal to 0. And net force 0. It means that the object has translational equilibrium. But when the question says slow down from rotation, it means that angular speed decreases. When angular speed decreases, delta omega is not equal to 0. Change in angular speed is not equal to 0. When change in angular speed is not equal to 0, it means that the object has angular acceleration. Angular acceleration also is not equal to 0. So that is why net torque is not equal to 0 and the object has no rotational equilibrium. The object has only translational equilibrium. Ceiling fan rotates and slows down once the power is turned off, so that the fan has, or the ceiling fan has what? Has only translational equilibrium. Why? Because it says slow down. A ball is thrown into the air. Be careful. This is very important. A ball is thrown into the air. In that case, this object has only rotational equilibrium, not translational equilibrium. Why? Because when we say the ball thrown, it means that the ball doesn't rotate. Okay? The question does not say the ball is rolling. Guys, be careful. When the question says thrown without rolling, it means that this object, its change in angular speed is 0. Okay? So, when change in angular speed is 0, net torque also equal to 0. When the ball is thrown into the air, in that case, the gravity affected this ball. In the case when the ball is moving upward, its velocity decreases until it reaches the peak, the maximum point. As you learn in grade 11. At maximum point, its velocity reaches 0. So when the ball is moving downward due to the gravity, its speed or velocity increases. Okay? So that is why delta V is not equal to 0 when the ball is thrown into the air. Because the gravity affected this. Okay? So when delta V is not equal to 0, so it means that net force is not equal to 0. The object has only rotational equilibrium. Okay? Okay. Let's solve the questions, the solving questions that related with the translation and rotational equilibrium. Okay? But we are going to start from question 18 in chapter review. Okay? After that, we go back to the sample problem and the practice. Okay? Look at this question. Question 18. A window washer is standing on a scaffold supported by a vertical rope at each end. Okay? So, what we have? A window washer is standing on what? Scaffold. Okay? So, at first you have to draw a scaffold. Okay? This is a scaffold supported by a vertical rope at each end. How many ropes do we have? 2. FT1 FT2, the scaffold supported by 2 vertical rows at each end. The scaffold weight is 205 Newton. As I mentioned before, where does the center of the gravity located? You have to say the center of gravity for the uniform object. In this question, the scaffold is uniform. For the uniform object, the center of gravity is located at the center. Okay? Located at the center. What is this? This is Fg of the scaffold. Fg sub S, it means that the gravitational force for the scaffold is equal to 205 Newton. So the scaffold is 3 meters long. Okay? The scaffold is 3 meters long. Okay? So this is the distance of the scaffold. What is the force? What is the force each rope exerts on the scaffold? So what is unknown? Ft1, Ft2 is unknown. Okay? So if you know the scaffold went 600, sorry, this is not 57, this is 675. Correct it, please. When 675 worker stands 1 meter from one end of the scaffold, from one end, the question didn't indicate that the worker is located from the right rope or the left rope. So that is why it's up to you. Okay, so you can put the worker here near Ft1 or near Ft2. It's up to you. Both are correct. Okay, so in this question we try to put the worker near Ft1. Okay, the question says if the worker, this is worker, its gravitational force is Fg worker 675 Newton, located 1 meter from one end. From one end. See that from this end. Okay, so this is 1 meter. Okay, how can you find Ft1 and Ft2? Okay, as I mentioned before in the note, in this question for the rotational and translational equilibrium, if 2 forces are given, or the question asks us to find both forces, in that case we have to apply and use both translational equilibrium and rotational equilibrium. Okay, how many forces unknown in this question? 2 forces. To find the first force, we have to use the rotational equilibrium. To find the second one, we have to use the translational equilibrium. In this way, we can find both forces. Okay? For the first one, always you have to use rotational equilibrium. According to rotational equilibrium, net torque acting on the scaffold is 0. Okay? So it means that the scaffold doesn't rotate. The scaffold at rest, net torque is 0, and also its position doesn't change. It means that this object has 0 velocity, so that is why it has translational equilibrium as well. Okay? When net torque is equal to 0, it means that all torques that acting upward is equal to all torques that acting downward. Okay? So, in this question, without axis of rotation, we cannot solving the question. To find Ft1, we have to make Ft2 as axis of rotation. Okay? Axis of rotation is arbitrary. It's up to you. If you make Ft1 as an axis of rotation, so you have to find Ft2 after that Ft1. But to find Ft1, we have to select the axis of rotation on Ft2. Okay, so where is the axis of rotation? The axis of rotation is located here to find Ft1. Okay, because the axis of rotation is located at the end, you have to equalize all torques upward and all downward torques. Okay, how many upward forces do we have? We have 2 upward forces. It means that we have 2 torque. Okay, the torque of torque number 1, Ft1, plus torque number 2, Ft2, is equal to all torques downward, Fg scaffold and Fg worker, is equal to the torque of the scaffold plus torque of the worker. Okay, so according to the equation of the torque is equal to what? Is equal to Ft1, this torque, times d1 plus Ft2 times d2 is equal to the torque of the scaffold, which is rotating clockwise, okay, is equal to Fg scaffold times the distance of the scaffold from the axis of rotation plus Fg worker times the distance of the worker from the axis of rotation. Okay, what is this? This is Ft1. Ft1. What do we mean by d1? In the equation of the torque, when we say torque is equal to Fd, this distance is the distance from the applied force to the axis of rotation. Where is the applied force for the Ft1? Here. Where is the axis of rotation? This is axis of rotation. How long? 3 meters. So that is why d1 is equal to what? 3 meters. Distance from applied force to the axis of rotation. What about d2? d2 is equal to 0. Has no torque. Ft2, its torque is equal to 0. Okay, so that is why we have to make F2 as axis of rotation to find Ft1. Okay, because the force acting on the axis of rotation. Be careful. Okay, so what about Fg scaffold? The Fg scaffold gravitational force is located at the center, so that is why is located at the middle. As you know, the length of the scaffold is 3 meters. If you make this 3 meters into two same part, okay, so this distance becomes what? 1.5 meter. Okay, 1.5 meter. This is the distance of the scaffold from axis of rotation. Okay, or you can write here the distance of the scaffold is 1.5 meter because it's located at the middle. The entire length of the scaffold was given is 3 meters, but because the center of the gravity located at the middle, you have to make this 3 meters divided by 2 to finding the distance of the scaffold. The distance of the worker is very important. Listen carefully, please. This worker is 1 meter away from this force. Okay, so we don't need this one, please. The gravitational force of the worker is applied at this point. The distance from the gravitational force to the axis of rotation is equal to what? 3 minus 1. 2 meters remain here. So the distance of the worker is equal to what? Is equal to 2 meters. By the way, you can replace the value and to find Ft1. Ft1 is unknown times d1, 3 meters plus 0. Ft2 cannot produce torque because it is located on the axis of rotation. Fg scaffold was given 205 times the distance of the scaffold 1.5 meter plus Fg worker 675 Newton. The distance of the worker to the axis of rotation is equal to 2. Okay, according to Math Basic, you can find Ft1, which is equal to 552.5 Newton. This is Ft1. This is the first unknown in the question. To find Ft2, you have to use the translational equilibrium. Okay, every time to find the second force, use the translational equilibrium. Okay, in the translational equilibrium, net force is equal to 0. All upward force equal to all downward force. The forces that are acting upward, how many forces do we have? 2 forces, F1 and F2, or Ft1 plus Ft2, all upward force that acting on the scaffold is equal to all downward force. How many forces do we have that acting downward? 2 forces, Fg scaffold and Fg worker. Okay, Fg scaffold, Fg worker. So in that case, what is unknown? Ft2. Ft2, we have to take Ft1 to the other side. So Fg scaffold plus Fg worker minus Ft1. Ft2, Fg scaffold was given 205 plus 675 minus Ft1, we found 552 52.5. So FT2 is equal to what? Is equal to 327.5 Newton. Okay, so this is question 18 in chapter review. Very good question. Be careful. Okay, we have another question. It's look like this question, question 18. I'm going to solve the similar questions. Look at question 2 in practice 2B. Question 2 in practice 2B, okay? The question 2 also we have a window washer. So this question has been brought this year, 2023, 2024. A 700 window washer is standing on a uniform scaffold supported by a vertical rope at each end. The scaffold's weight is 200 Newton and 3 meters long. What is the force in each rope when the window washer is standing 1 meter from one end? This question is the same question of the chapter review question 18. Two forces are given and two forces are unknown, Ft1, Ft2. Okay, to find each force we have to apply both conditions, rotational equilibrium and translational equilibrium. For the rotational equilibrium you have to find Ft1. Okay, when we use when we use the rotational equilibrium we have to make F2 as axis of rotation. Okay, when we make F2 as axis of rotation we have to find Ft1. How can we find Ft1? By using the rotational kinetic, rotational equilibrium. Sorry, in rotational equilibrium, net torque is equal to 0. All upward torque is equal to all downward torques. How many upward torques do we have? We have 2, Ft1, Ft2. Okay, so that is why you have to write down Ft1. Sorry. Torque number 1 plus torque number 2 is equal to the torque of the scaffold plus torque of the window washer or worker. Okay, so according to the equation of the torque, torque is equal to what? F1 d1, F2 d2. The torque of the scaffold is equal to Fg scaffold times the distance of the gravitational force of the scaffold to the axis of rotation, plus Fg worker times the distance of the worker from the axis of rotation. F1 is unknown. D1, because the entire length of the scaffold is 3 meters, so that is why D1 is equal to 3, plus F2 times D2 is 0. Why D2 is 0? Because located on the axis of rotation. Okay, so that is why this term cancelled. Okay, Fg scaffold was given 200 Newton. The distance of the Fg scaffold from the axis of rotation, because the scaffold is uniform, so that is why we have to divide this 3 meter by 2 is equal to 1.5 meter. This is the distance of the scaffold from axis of rotation. Plus Fg worker was given 700 Newton times the worker stand is 1 meter from one end. It's up to you if you put the worker here from this end. So what is the distance of the gravitational force of the worker to the axis of rotation is 2 meter. Okay, is equal to what? Is equal to 2 meter. Okay, so F1 is equal to what? Is equal to 567 Newton. So this question has been brought in this year in 2023 to 2024 with the same number without changing number. To find F2 you have to satisfy or apply the the translational equilibrium, condition of translational equilibrium, which is equal to the upward force is equal to downward force. F1 plus F2 is equal to Fg scaffold plus Fg worker. By this way, you can find F2, which is equal to 333 Newton. Okay? Okay, guys. Question 1. Question 1 in practice 2B. Let's solve this question. So I got many requests from the students to keep uploading the lesson. Inshallah, as I promised you, I'm going to upload the entire chapter, and I'm going to explain the entire chapters of physics for grade 12 students. Okay? Look at question 2B. Very good question. Listen carefully, please. A uniform bridge, it means that its center of gravity is located at the center. Its length is 20 meters. The length of the bridge is 20 meters. Okay? Assume that this is bridge. Its length is 20 meters. Okay? Its weight is 4 times 10 to the power 9, 10 to the power 5 Newton. What is this? This is the FG of the bridge located at the middle. What is this? This is FG bridge is equal to 4 times 10 to the power 5 Newton. Supported by 2 pillars located 3 meters from each end. What do you mean by 3 meters from each end? It means that we have 2 pillars is located 3 meters from each end. Okay. How many pillars do we have? Because the bridge is supported by these 2 pillars. Okay. Let's put it on these 2 pillars. Each 3 meters from each end. 3 meters here. Okay. The distance from this pillar to this end is 3 meters. The distance from this end to this pillar is also 3 meters. What is remain here? 20 minus 3 minus 3, which is equal to 14. Okay. So what is remain here? The remain length here is 40 meters. Why? Because the entire length of the bridge was given 20 meters. But the pillar located at each end, 3 meters from each end. So we have to subtract this 20 by what? 3 plus 3 is 6. 20 minus 6 is equal to what? What is remain here? 40 meters is remain here. Okay. If 1.96 times 10 to the power 4 Newton car is parked 8 meters from one end, it's up to you. Okay. So we will put the car from this end. Okay. So it's up to you. You can put the car from this end or this end. Okay. According to this figure, so we're gonna put the car from this end. Okay. So 8 meters from this end. Okay, this is Fg of car. Fg sub c, it means that the gravitational force of the car, which is equal to 1.96 times 10 to the power 4 Newton. Okay, so how much force does each pillar exert? How many pillars do we have? 2 pillars. How much force does each pillar exert on the bridge? Assume that this is F1, the force of the first pillar exerted to the bridge, that is acting upward because the bridge is put it on the pillar and the pillar is acting an upward force. Okay, this is F1 and this is F2. Okay. How many forces unknown? 2 forces. F1 is unknown, F2 also unknown. If 2 forces are unknown in the question, be careful, you have to use both rotational equilibrium and translational equilibrium. To find the first force, F1, we have to use rotational equilibrium. For the second force, we have to use translational equilibrium. So, do we have axis of rotation? No. So, the axis of rotation, so the selection of the axis of rotation is arbitrary. It's up to you. Okay, so you can make F1 as axis of rotation, and also you can make F2 as a axis of rotation. To find F1 at first, I have to make F2 as a axis of rotation. Now, do we have axis of rotation? Yes. F2 is, or pillar 2 is axis of rotation. Okay? To find F1, we have to use rotational equilibrium, which is equal to net torque is equal to 0. So it means that all torque is that acting upward, because the axis of rotation is located at one end. We have to equalize all upward torque to all downward torque. Okay? Okay. How many torques do we have that acting upward to? F1, F2. Torque number 1, torque number 2. It means that the torque of the first pillar and the torque of the second pillar is equal to the downward torque. It means that the torque of the bridge plus the torque of the car. Torque of bridge plus torque of the car. Okay? According to the equation of torque is equal to what? Torque number 1 is equal to F1 D1. Torque number 2 F2 D2. Torque of the bridge, which is clockwise, it means that the force Fg of the bridge times the distance of the gravitational force of the bridge to the axis of rotation, plus torque of the car. It means that Fg car times the distance of the car. Okay? Guys, listen carefully. How can we determine the distance? Because each force has a different position. So that is why the distance from each force is different from each other. Be careful. Okay? According to the equation of the torque, when we say torque is equal to Fd sine theta, if you remember, what is this distance? It's the distance from applied force to the axis of rotation. Okay? For the first one, F1, what is the value of D1? The value of D1 from, we have to consider from this point to this point, to the axis of rotation. How many meters do we have? 14. Okay? Don't write 20, please, because the pillar is located 3 meters from each end. So we have to cut this to 3 meters. What is remain? 14. 14 meters is remain. Distance from applied force, first pillar, to the axis of rotation. Okay? F1 times 14 plus F2 is unknown also, but it is located on the axis of rotation. So D2 is equal to 0. No torque produces from at this point. F2 cannot produce torque, so that is why is equal to 0. Fg of the bridge was given 4 times 10 to the power 5 times the distance of the gravitational force of the bridge to the axis of rotation. If the distance from this first pillar to the second pillar is 14 meters, okay, so you have to divide this 40 by 2. So what is remain? 7 meters. The distance of the bridge is equal to what? 7 meters. Plus the distance of the car. Be careful, this is very important. Don't use this 8 meters, please. Because the distance of the car was given from the end, not from the pillar. The distance of the car is 8 meters from this end. From what? From this end. Okay? So, because you know that we have this 3 meters here, and we have to consider the distance from the car to the axis of rotation. 8 minus 3, what does remain here? 5 meters remain here. The distance of the car. Okay? The distance of the car from the axis of rotation is 5 meters. Because this 8 meters was given from the end, not from the axis of rotation. Between the pillar, the axis of rotation, and the end, we have 3 meters. We have to subtract this 8 meters by 3. What is remain? 5 meters. Fg of the car was given 1.96 times 10 to the power 4 times 5 meters. According math basic, you can finding F1, which is equal to 2.07 times 10 to the power 5 Newton. Okay? So this is very important. Be careful. For the second force, the force that exerted on the second pillar to the bridge, you can use the translational equilibrium, which is equal to F1 plus F2 is equal to Fg car, Fg bridge plus FG of the car. Okay? In that case, F1 plus F2 is equal to FG bridge plus FG of the car. Do we have F1? We didn't have, but we found it. F2 is unknown. We have FG of the bridge and FG of the car. Rearrange, take to the other side to find the F1, the force of the second pillar that exerted on the bridge. Okay? So that's all for today. Hope you get understand it and get benefit from my lesson. Thank you for the listening. Wish you all the best and see you again, inshallah.